Okay, welcome back guys to my video series on arithmetic progression and series. So in this video we are going to be talking about the sum of terms of an AP, okay, or the sum of terms of a linear sequence. My name is George Boma Smith. Okay, let's proceed. So in the previous video we discussed about the arithmetic progression, and then we gave this term that this is how the arithmetic progression looks like. So you have a plus d, which is the second term, you have a plus 2d, which is the third term, and that's how it proceeds. But what if you want to sum these terms, which is what you call a series? Generally series are simply a sum of terms in a sequence. For the series you have something like this, you're adding all the terms. Now one thing you have to notice is that sequences and series are generally infinite. You don't know how many terms you have in them. They are always infinite. So what we'll basically do is to try to consider a few terms. Okay, so since the sequence is infinite, the series also is infinite. Generally series are infinite. That's why if you look at the general expression we have for sequence, we said n has to start from 1 to infinity. So this can be restructured in a way. Remember the nth term of an AP, we said it is a plus n minus 1d. We said this is the formula we use, a plus n minus 1d. So the same thing, what I can do here is to sum these terms. Okay, I have to sum this. So if you sum that, you use this notation for it. We have the sum of a plus n minus 1d. Now I'm not using n here, I'm using r. You can go ahead and use n. If you're using n here, you make this one to be n. I just decide to use r, and later on you see the reason I decide to use r. Okay, so you can see this is summing r starting from 1 down to infinity. Some books will use r starting from 0 to infinity, and then they will modify this, but here we are making it simple. Generally r starts from 1 down to infinity, so it's infinite, and that's going to lead us to this is it. And what if we decide to sum just a few terms and we don't want to sum all the terms? You want to sum the first n terms. N could be 1, n could be 2, n can be 20, n can be 3. But in as much as you're not taking the sum of everything, you want to look at the few terms. This is what you're going to have now. Now the difference between these two expressions is that here we have infinity, but here what we have is n. That's the difference you have between these two expressions. Okay, and again, so we're just saying sum here, we are saying the sum of the first n terms. Now whenever you have the sum of the first n terms, this is what you call the nth partial sum. Take note of that. Very important, this term. We call it the nth partial sum. So it means if I'm summing the first two terms, it is called the second partial sum. If I'm summing the first three terms, it is called the third partial sum. But since I'm summing the nth term, the first n term, we call it the nth partial sum. Now some series actually have a valid value when you sum them, the infinite term to be precise. But for the arithmetic progression, this infinite sum always doesn't have a value. For that reason, the arithmetic series is what they see as what you call the divergent series. Okay, take note, it is divergent. Divergent means you can't get a value when you sum infinitely. It is impossible for you to get a value, so it doesn't converge to a particular term. So it's actually a divergent series, the arithmetic series. Take note of that. So this nth term, if you've gone through a book or two, you'll notice that this is not what you usually see in those books. Okay, they don't use this. There's the formula. You can actually simplify this one too, of which we are not taking the proof. But if I simplify this expression, this is what I'm going to get. It's n over 2 into 2a plus n minus 1d. That is when you know the first term and then you know the common difference. But you can also use this, which is n over 2 into a plus l. In this case here, l here is called the last term. Okay, that's what we'll call it. L is called the last term. And what the last term simply means is that it is that nth term of your arithmetic progression. That's just what the last term means, the nth term. Because if you look at it very well, in place of l, if I put this, what I'm going to get is a plus a, which is 2a, and every other thing remains the same, which gives you back this. Okay, so that's what you call the arithmetic series and the formula. So now we've seen the arithmetic progression, we've seen the arithmetic series, we've not taken an example on them. In the next video, that's what we'll be doing. We'll be taking examples on this so that it will help sync the concept we just discussed on arithmetic progression and arithmetic series. Okay, so that's it guys for this video. I'll see you guys in the next video. Bye bye.